Welcome to a short presentation from TC Communications. I'm Steve Cragg, the VP of Sales and Marketing at TC Communications. What we're talking about today is a fairly common problem for many of our customers in the fact that they are looking to take their legacy equipment, which often communicates using either a hard to get, obsolete, or difficult to use format, and they want to run that equipment over a broadband network. And often the decision process looks in this way. I say new network, in this case, broadband network, and they have their existing equipment. And the first point is, okay, let's connect the existing equipment to the new network. And unfortunately, that equipment doesn't have IP or Ethernet connectivity capability. The next discussion typically is, well, then if it doesn't have that, then let's get rid of that equipment. We won't use it anymore. But then the problem then is, well, perhaps the lights go out because that equipment is still performing a very valuable job for you. So just getting rid of that equipment and not using it anymore is not an option. So then the next one is, well, let's replace that equipment. And of course, that does come with a cost of purchasing that new equipment. And quite normally, it's quite usual that the very reason that the customer is still using the existing equipment and not replacing it with new equipment is for reasons of cost. So it is fairly rare that there's an oversight, that somebody just forgot that they couldn't connect that equipment, but it is very common that the equipment is being used and there is a desire to move it over the new network, often because things such as lease lines, T1s, and so on, that the original equipment was connected via, is becoming difficult to maintain, hard to get, expensive, and so on. So what is the solution? Well, the solution here is come and talk to TC Communications. This is very much what we do. We will give you a means to connect your existing equipment over typically 3 transport media, Ethernet, which is what we're going to talk about in this presentation, but we also transport over T1 and dark fiber as well. So if those are of use, we do have that, but what we're talking about here is specifically talking over or connecting over Ethernet. And the product that we're going to use for that is our JumboSwitch range. I'm just going to give you the very brief introduction for that range. If you do want to find some more information, there are videos and literature on our website regarding this. So the JumboSwitch is a mission critical piece of equipment. And as you can see, it has all of the existing or all of the expected functions that you would, or capabilities that you would have. So completely solid state, fully redundant power, extended temperature range, IEEE 1613, for substation use, as well as hot swappable. All of the cards are hot swappable to minimize the downtime and maintenance costs. Although we do have a 5-year warranty, that's how confident we are in our equipment. And in fact, it all has greater than 300,000 hours MTBF. So that's the equipment we're using. Basically, let's just very briefly explain how that goes together. We're going to use, in this case, we're going to use some RS-232 cards to show how this works. And basically think of a JumboSwitch solution as a large matrix. So any port on any card can be connected to any other port of the same type in the same network. So in this case, we've got RS-232 ports. It's done very easily with IP addressing. In this case, we're using the second octet to indicate the site number, and then the last one to talk about the actual card itself. So we've done that on both site 1 and on site 3. And now what we want to do is we want to connect up 2 ports, in this case both port 1s, on site 1 to port 1 of that card on site 3. And very simply what we do is we simply tell the card on site 1 what the destination IP address is. We do the same at site 3. We tell it which port is going on to which IP address on that. Give it a UDP port, unique UDP port at the same time, and then the cards simply sync up. It's as simple as that. It means that changing the layout of the system, connecting different ports to different other ports is very, very simple to do. And although I've shown here that in this case I did port 1 to port 1, there's nothing that says you can't connect port 1 of one card to port 4 of another, and so on and so forth. So very simple and setup. Again, if you're interested in learning more about that, we have a lot of literature and videos on our website. So now I'm just going to talk through some of the applications that we're talking about here, and just a subset of what we can actually do. Firstly, teleprotection, then SCADA, analog, phones, T1s, and Ethernet switching. So we'll go through these quite briefly, and we will talk about each of them and the benefits of using JumboSwitch for this over Ethernet. If you do want to learn some more, I would point you towards the product matrix. The product matrix shows all of these interfaces over the various transport media that we use. And we also have the IEEE 1613 solution guide, and that solution guide is designed to show you all of the products that meet the IEEE 1613 specification for substation use. So let's get into the applications. Teleprotection, let's start with C3794. I think you should all be familiar with this. This is a fiber-based solution. Our cards, it's called the TC3846-2, full C3794 compatibility. And key to making this work for teleprotection is extremely low latency. What you will typically see is latency of under 5 milliseconds from port to port. So you can use this in all of the teleprotection requirements, even the extremely high voltage ones as well. Works exactly the same way as before, so it's very easy to connect a relay on one port to a relay on a card at another site on another port. So that's very easy. As I mentioned, great flexibility, and a thing I didn't mention before, and you can see to a small extent on this diagram here, there's a variety of mounting options as well. So if you just need a single card, there's a single standalone unit. You can just wall mount or tray mount right through to multiple 4U racks if you have a large central site. So that was C3794. We'll now talk about teleprotection with serial. And this is used on a different one. Again, a different card to provide what you need to do. Again, extremely low latency. And because of how we handle the serial, fully mirror bits compatible. So let's just talk about how that is achieved, because it's quite interesting, both from the mirrored bits and from the low latency point of view. And really, there's a couple of ways you can approach this. Perhaps the most common way is to take a serial device, connect it to a receiving device similar to our JumboSwitch. That would receive all the serial data, or it would store it, buffer it, convert it to packets, transmit it as packets at the other end. It receives all the packets, puts it back into serial format, and sends it out. We don't like that because that does mean that the receiving device does have some data stored. It's relatively high latency as you have to wait for whole bytes to be received before you can transport them. And because the data is buffered, potentially lower security, it means one more device that actually does have on your network some of that data. So what we do is we do oversampling. This does come at a cost, slightly higher bandwidth, but not significantly. And what this means is the waveform is oversampled. So it's treated almost as though it is an analog wave rather than a serial one. This means that each sample shown here in red is packetized and transmitted. Because you can take multiple samples for a single bit and packetize them and send them to the other end, it means that extremely low latency, because the data doesn't have to be received and stored, buffered and sent out. It means that it essentially starts appearing out at the other end almost instantaneously from when it's received. It also means that it's higher security. My personal favorite, which isn't on this list of benefits, is the fact that because we oversample, we don't have to worry about necessarily baud rate. We do need to make sure that we oversample higher than your baud rate, but we don't need to worry about baud rate. We don't need to worry about the number of data bits, the number of start bits, the number of stop bits, the number of parity bits, etc. So we don't have to interface to your unit. We just take the serial sample it, and reconstitute it at the other end. It doesn't matter to us which it is. So you're not going to be sitting down going, wow, do I set this to 1 stop bit, 2 stop bits? Is there a parity bit? Is there more error correction or whatever? It just simply passes it from one end to the other. So let's just talk briefly about SCADA. Here's a few options here. We have a classic serial server, again, mission critical. We also have you can use this with serial tunneling, and that will support RS-232, synchronous and asynchronous, as well as 422 and RS-485. Supporting speeds up to 33.4 kilobits per second. So should meet all of your SCADA needs. Extremely easy to set up, as I mentioned before. Very easy to reconfigure the system should you need to as well. So that's SCADA just very briefly. Let's talk about analog, which is the next application. I'm going to start by talking about two-way radio. We still see a lot of analog two-way radio being used in the utility and other fields. And our 3846-6, which is our 4-wire E&M solution, is particularly well suited for that. It has both 600 ohm transmit and receive audio. It also has dry contacts and relays for the E&M signaling. So while it's also used for two-way radio, it's equally as useful for things such as modems, etc. One of the things that is particularly useful is the fact that we provide no distortion and there's no compression used for the audio, which means that between the full range of 300 to 3 kilohertz, the full bandwidth of the audio path is available. This means that if you are using control signaling, particularly in two-way radio, where you use guard tones and so on, those work seamlessly. And again, the low latency will work with such things as simulcast radio as well as providing you with a very reliable modem solution. Next application is phones. I don't want to spend too much time on this. A lot of people moving towards voice over IP, but we do still see a lot of analog phones being used. We have a couple of options, well, it's actually many options, but two key options here. One is extension of phone lines either from PBX or the PSTN. That will be FXO to FXS, as well as crash phones, so FXS to FXS. And as you can see here, providing a variety of interfaces, pretty much anything you can connect to a phone line, you can connect to this device. If you want to learn some more about some of the more specialist applications using some of this around phones, I would suggest having a look at this video. This talks about particularly the use of phones to provide NERC CIP compliant for when third-party generation customers wish to connect to utilities. As we mentioned before, IEEE 1613, we see a lot of phones, analog phones, still being used in substations, and we have a full range of products that connects the phones and are IEEE 1613 compliant. Coming towards the end of the applications now, T1s. While T1 use has reduced over the last few years, we do still see a lot of customers still having equipment connected via T1s. What we are seeing is that the telcos are steadily making this more difficult to use, either through not making them available, not keeping them reliable, or very commonly, significantly increasing the cost. And so or customers will often come to us and say, can you provide us a T1 that operates over our broadband network? And the answer to that is absolutely we can. We have a 4-port device, again, any port to any other one. So it can be used point to point, as it's shown in the top one here, or point to multi-point or multi-point to multi-point T1. So very efficient way of using a device to provide T1 communication without actually having to involve the telco and instead using the bandwidth of your own network. Last application, I think it's an important one to cover here as well, is not only does the JumboSwitch have these interface cards that can provide the applications I've already talked about, but it is a full multi-service Ethernet platform. We have a device, the TC3850, which is a 10G solution. You can see this on the top right-hand corner of this presentation slide. However, it is perhaps unique in having capability down below to either increase the number of Ethernet or SFP ports, or to put in interface cards, as we've already spoken about as well. So it can be used to generate the core Ethernet switching solution, or it can be used as an edge device, or both. Similarly, you can also do the same thing using the JumboSwitch. In this case, we're showing a 4U rack. In this case, it uses our inbuilt management card, which provides a 2.5 gigabits ring, again using fiber. And these can be used again as core or edge devices as well. For those of you who don't know about TC Communications, we are a California, US-based company, been in business for over 30 years. Our speciality is in TDM communications in mission-critical environments. And all of our design, manufacturing, support is done out of our Irvine, California facility. So all products are made in the USA, fully TAA compliant. I hope you found that a useful presentation. Thank you for listening. If there's any further questions, feel free to reach out. Here's our contact details and so on. And as I said, there's a lot more information on these. If any of those topics are interesting to you, please check out our website or contact us for more information. We have a wealth of both literature and videos on our website. Thank you very much.